Hello, my name is Sweetisha and welcome to our channel Coding with JS, where we learn comparison operators and the key difference between basis and thousanders and thousanders.
Comparing two values sounds like it should be simple. But JavaScript gives you two different equality operators. Two equal signs and three equal signs. Every style guide tells you to use the three-sign version. Very few of them explain what the other one actually does. Today we will walk through the exact algorithm. Then the advice will make sense instead of being a rule. Let us start with the strict version, which is simpler. We compare the number 5 with the string 5. Strict equality checks the types before anything else. A number and a string are different types. So the answer is false immediately with no further work. No conversion happened at any point in that comparison. That predictability is exactly why it is the default. You can read the line and know what it does. You never need to think about hidden conversions, which means reviewing someone else's code becomes much faster. There are no invisible steps happening behind the comparison. Now the loose version using two equal signs. Same two values but a different operator. This time the answer that comes back is true, because loose equality converts before it compares. It sees a number and a string, so it converts the string. 5 and 5 are now equal, so the answer is true. That conversion follows a defined algorithm. The specification lists the steps in a strict order. First, if both values are the same type, compare directly. In that case, loose and strict behave identically, which is worth knowing because most comparisons are same type. So in everyday code, the two operators usually agree anyway. The disagreements only appear when types are mixed. The second step is a genuinely special case. Null and undefined are considered loosely equal to each other. And they are not loosely equal to anything else at all. Not zero, not an empty string, not false. Only each other, which is a deliberate design decision. The specification carves them out as a special pair. With strict equality, they are different types and so unequal. That special case gives us the one genuinely useful loose check. Writing x loose equals null catches both null and undefined. It is a concise way to ask, is this value missing? The strict version would need two separate comparisons. So this is the one exception most style guides allow. Every other loose comparison is better written strictly. Some teams ban even that one for total consistency. Optional chaining has also reduced how often you need it. Let us walk through a genuinely confusing example. Comparing an empty array with false gives true. That result gets posted online as proof of madness. But every step of it follows the algorithm exactly. Step 1 asks whether the types match. An object and a Boolean, so they do not match. Step 2 is the null case, which does not apply here. Step 3 says a Boolean always becomes a number first. So false turns into the number 0. Now we are comparing an empty array against 0. Step 4 says an object must become a primitive. An empty array joins its 0 elements into an empty string. Now we are comparing an empty string against 0. Step 5 says a string compared to a number becomes a number. And an empty string converts to 0, as we saw earlier. So finally we compare 0 against 0, which are equal, giving us the answer true. 4 conversions happened in a single comparison. Every one of them was invisible in the source code. That is the real argument against loose equality. Not that it is random, but that it hides work from you. You cannot read a line and know what it does. You have to run a 6-step algorithm in your head, which nobody does reliably at 9 in the evening. Code should be obvious when you are tired, not just when fresh. There is one more surprise, and it affects strict equality too. We compare NaN against itself using three equal signs. And the answer is false, which looks completely wrong. NaN is the only value in the language not equal to itself. The reasoning comes from the floating point standard. NaN means the result of some invalid calculation. Two invalid calculations are not necessarily the same thing. 0 divided by 0 is not the same as the square root of -1. So the standard decided they should never compare as equal. JavaScript inherited that decision along with the number type. So this behavior is shared by almost every language, which means you cannot test for NaN with a comparison. Use number.is NaN instead, as we covered earlier. There is a third comparison function worth knowing. Object.is behaves almost exactly like strict equality, with two very specific differences. It says NaN is equal to NaN, which is often more useful. And it distinguishes +0 from -0. Strict equality treats those two zeros as identical, which is usually what you want, so this rarely matters. It mostly appears inside library code doing careful comparisons. You will not reach for it often, but recognize the name. So let us state the practical advice clearly. Default to 3 equals signs for every comparison. It never converts, so it never surprises you. Most linters will flag the loose version automatically. The one accepted exception is comparing against null. That single check catches both null and undefined neatly. And remember, NaN is never equal to anything, including itself.